And welcome back to Algebra. We are in the second part of Chapter 5, Section 3, using point-slope form. So I hope you had a happy Halloween and welcome back. Today we are going to use point-slope form to write a linear equation. And so can you, without looking, recall point-slope form? And yes, I hear it now. It is y minus y1 equals m times x minus x1. So today we are going to take a look at a graph. So here's a graph. And we are going to write the equation for this graph using point-slope form. All right, so if we're going to use point-slope form, let's jot down the model of point-slope form. And what do we need from the graph? That's right, we need slope, and we need this one named point, right? x1, y1 is a single named point. So we actually have 2 points named here, and so we can use them, either one of them, for our point. Why don't we just use the one that has a 1 in it? That's a nice one to use. So we'll use 1 and -3, that's our point. And then we do need our slope, don't we? We need the slope. So m can be found just moving from a point on the line to another point on the line, right? So we like moving from left to right. That can be, it's just a nice consistent way to find our slope. So if we're going from -2, 3 to 1, -3, we're going to have to go down how many? It looks like we're going to go down 6, right? -6. And we're going to walk 1, 2, 3. So the slope is down 6, and the run is 3. So when we reduce our slope, we end up with a slope of -2. Good. So now we're going to take these two critical ingredients, our point and our slope, and substitute them into point-slope form. So let's start. We have y minus, which is y1? -3, right? Y minus -3 equals, m is -2, so -2 times x minus, and our x value is 1. That's right. Okay, so we have now written this equation in point-slope form. We can actually take it the next step and transform it to our favorite form, slope y-intercept, right? As we look at the left side of this equation, how could this be simplified? Good, we can add the opposite, right? So y plus 3 equals -2 times x minus 1. To transform it to slope-intercept form, we need to isolate y, right? Before we do that, let's simplify both sides of this equation. So let's distribute -2 to both terms on the right side before we move anything across the equal sign. So y plus 3 equals -2 times x, or -2x. And then we have -2 times -1, right? Which is +2. Good. And now we're ready to isolate y. So how will we move the 3? Good. Subtract 3 from both sides of the equation, right? And let's draw a clean line. And the left side is y equals, and we end up with -2x. And 2 minus 3 is -1. Good. And so there is the equation in slope-intercept form, our favorite form. Slope-intercept form tells us the slope is -2, down 2 over 1, down 2 over 1, which is true, right? And the y-intercept is at -1. And yes, that is where the y-intercept is. This line crosses the y-axis at -1. Good. So let's move back up and put down the steps to using point-slope form to write an equation. And the first step was we used the graph to find slope. The second step, we substituted a point and slope into the point-slope equation. And the final step was transform your point-slope equation to slope y-intercept form. Y equals mx plus b. Okay, whoops, we are going to try this again. So go ahead and pause the video and see if you can write an equation in point-slope form of the line that passes through these 2 points. This is actually slightly different. The equation should end up being in point-slope form. You do not have to change this equation all the way to slope-intercept form. Okay, so go ahead and pause the video, see if you can do this. You can come back and walk through. Okay, as you recall, for point-slope form, what do we need? Point and a slope, right? So we're going to use either point in our point-slope form. When you have a point like 4, 4, that's really an easy substitution because you can't go wrong. You could never substitute into the wrong place of the equation. The x and the y are the same, right? And so the other thing we need is slope, right? So let's use our slope formula to find slope, right? M equals y2 minus y1 over x2 minus x1, which I'm sure you used, right? So now when we substitute the given values, let's use this as 0.1, and 4, 4 will be 0.2. So we'll say 4 minus 2. Ooh, whoops, I made a mistake, didn't I? It's actually 4 minus the y value here, which is 3, over 4 minus the x value, which is 2. Good, so our slope is 4 minus 3, 1, over 4 minus 2, 2. Our slope is 1/2. Good. And so now we're going to write the equation in point-slope form. Let's start with that form. Y minus y1 equals m times x minus x1. Okay, and we simply take our point, plug it in, right? So the y value is 4, and the slope we found was 1/2, and the known x value, the named x value, is also 4. So x minus 4. Good. There it is, in point-slope form. That actually answers this question because they are not asking you to write it in slope-intercept. If you were going to write it in slope-intercept form, what would you do with this? That's right, you would distribute, and then you would add 4 to both sides, right? Isolating y. Very good. Okay, you do not need to write this down, but I would like you to walk through this real-world linear model with me and really focus now. The table here shows the cost of visiting a working ranch for 1 day and night for different numbers of people. Can this situation be modeled by a linear equation? Explain. And if possible, write an equation that gives the cost as a function of the number of people in the group. How do we know if this is a linear equation? Do you remember? Well, recall we look and see, is there a constant change in the domain? So we can say that the x values, the input, are the number of people, right? So what is the change that we see in this table? And yeah, I'm sure you see it's +2, right? And so then we look at the range. What is the change in the range? And do you see that? The change is +100, right? So we know that the change in the y is 100 over the change in the x, which is 2, is going to give us what? That's right, it gives us slope. So this is a constant change, so we do have a linear equation with a slope of 50. Okay, so could we write the equation for this? Yes, we could, right? If we're going to use point-slope form, we simply use a slope, and what else do we need? That's right, we need a point, and you may use any pair that you see here. All of them could help us make this equation. So let's see how the book walks us through. So here they found the constant change, they found the slope, just like we did, right? And then they input, let's see which point they chose. Did they choose point 4,250? Let's see. Yes, they did. They chose the very first point, probably because it has the smallest numbers, right? They input that in for the x and y. Okay, they called the x p and the y c. Do you see that? They changed the variables, which is fine, right? It's still linear. And then they solve this for c, changing it to slope-intercept form. Slope is 50, and the starting point is 50, isn't it? So y equals mx plus b can be written with different variables. Excellent. So when you're facing word problems, we're going to look for points, and we're going to be able to find slope. If we have 2 or more points, we can easily find slope, can't we? Good job. Good luck, have fun, work hard.